Hello students, welcome to physics class. Today we starting a new chapter in physics, that is gravitation, chapter number 10 from NCERT textbook. We all observe that when you are dropping an object from certain height above Earth's surface, it falls towards the Earth. And also we know that the planet revolve around the sun or moon revolve around the Earth. Some cause is there for all this motion, or some force is responsible for all this motion. Sir Isaac Newton identified that the same force is responsible for all this motion, and that force is known as gravitational force. So in this chapter, we are going to study what is gravitational force, the law of gravitation, that is universal law of gravitation, acceleration due to gravity, motion under gravity, and later how the weight of an object change according to the place in Earth's surface. Let us see what is gravitational force. The gravitational force. The force of attraction between any two bodies in the universe is called gravitational force. That is, the force of attraction between any two bodies in the universe is called gravitational force. Every bodies in this universe attract each other. There is an attractive force between every object in universe, and that attractive force is known as the gravitational force. For example, the earth attract moon, the sun attract all planet. Like every object in the universe attract each other. That attractive force is known as gravitational force. And what is the magnitude of this gravitational force? In order to calculate or in order to find what is the magnitude of this gravitational force, Sir Isaac Newton gave a law which is known as universal law of gravitation. According to Sir Isaac Newton, or according to this universal law of gravitation, every object in the universe attracts every other object with a force which is proportional to the product of their masses and inversely proportional to square of distance between them. The force is acting along the line joining of the center of the two objects. That is, every object in the universe attracts every other object with a force which is proportional to the product of their masses and inversely proportional to the square of distance between them. The force acting along the line joining of the center of two objects. In order to illustrate that law, let us see. Here we have two objects, A and B. Say the mass of A is capital M and the mass of B is small letter m. These two masses are separated by a small distance, say d. These two bodies are separated by a distance d. Actually, d is the distance between the center of these two bodies. Then, according to universal law of gravitation, the force between these two bodies is directly proportional to product of their masses. That is, the first body having a mass capital M and second body having a mass small letter m. So product of their mass means capital M into small letter m. The force is directly proportional to product of this mass. It means that if any of this mass increases, the force between the two objects also increases. If capital M increases, force will increases. If small letter m increases, force increases. That is, the force is directly proportional to product of their masses. And the second factor is force is inversely proportional to square of distance. Force is inversely proportional to square of distance. It means when the distance between the two objects increases, the force decreases. Actually, d is the distance between the center of these two objects. If d increases, force decreases. If d decreases, force increases. That's the meaning of inversely proportional. The F is proportional to 1 by d square. You can read it as F is proportional to 1 by d square, or F is inversely proportional to d square. The meaning is nothing but If D increases, force decreases. If D decreases, force increases. And together we can write as F is proportional to capital M into small letter m divided by D square. The force is proportional to capital M into small letter m by D square. So actually this is a proportionality. So we can remove this proportionality just by multiplying by a constant. So we are writing as F is equal to G into capital M small letter m by D square. We introduce a proportionality constant G here. And this proportionality constant G is known as the gravitational constant, universal gravitational constant. Capital G is known as universal gravitational constant. And in order to remove this proportionality and make it to equation, we introduce a constant, and that constant of proportionality is known as universal gravitational constant. The symbol is capital G. Okay, and we can write this expression for the G is equal to the gravitational constant. G is equal to, rearrange this equation, take this D square to left side, that's F into D square divided by capital M into small letter m. So this is the expression for G, gravitational constant. The gravitational constant G is equal to F into D square divided by capital M into small letter m. This is the expression for universal gravitational constant. Let us find what is the SI unit of this gravitational constant. In order to find this SI unit of gravitational constant G, so in the equation for G, substitute the unit of F. You know the unit of F is Newton, force, Newton. And D, the distance, actually D square. So that's why meter square. The unit of distance is meter. So actually here D square. That's why meter square divided by capital M, kilogram, mass. Then small letter m, mass, kilogram, unit. Kilogram into kilogram. That's kilogram square. So the unit of the gravitational constant is Newton meter square kilogram raised to -2. That is the SI unit of gravitational constant. And the value of gravitational constant G is found by the Henry Cavendish. The value of capital G is found by Henry Cavendish. And the value of capital G is universal constant. Universal gravitational constant is 6.673 into 10 raised to -11 Newton meter square kilogram raised to -2. That's the value of capital G, gravitational constant. So the gravitational force exists everywhere in the universe. Every object in the universe attract each other. They attract, the A attract B, similarly B attract A. So we can say the A is attracted towards B and B is attracted towards A. So this force is actually acting along the line joining of these two bodies. The gravitational force is actually acting along the line joining of these two bodies. And this force exists everywhere in the universe. Every object in the universe attract each other with a force F is equal to G into the product of the masses divided by D square. So in this equation for this force, if any of this quantity, that is if mass of the first body increases, the force increases. If mass of the second body increases, force increases. If mass decreases, force decreases. Then what about the distance? If distance increases, force decreases. If distance decreases, force increases. So that's the gravitational law, universal law of gravitations. Now let us see what is the importance of universal law of gravitation. The universal law of gravitation successfully explained several phenomena which were believed to be unconnected. That's the importance of universal law of gravitation. That is, the universal law of gravitation successfully explained several phenomena which were believed to be unconnected. Let us discuss such phenomena. The force that binds us the earth. We are able to stand on earth because of the attractive force of earth and us. Otherwise, we cannot stand here. The earth attracts us towards the center of the earth. That's why we are able to stand on earth. The second one, the motion of the moon around the earth. You know that moon is revolving around the earth in almost in a circular path. So it's able to move around the earth because of the attractive force between the moon and earth. We know that when an object is moving through a circular path, there is a force which is acting toward the center. If there is no force acting toward the center, the object cannot continue through the circular path. So that force we calling as centripetal force. The centripetal force means when an object is moving through a circular path, some force is acting toward the center. That force is actually directing the object through the circular path. That force we calling as centripetal force. So the required centripetal force for the moon is provided by the gravitational force between the earth and the moon. Then third one, the motion of the planet around the sun. The same concept. All planets revolving around the sun because of the gravitational force of attraction between the sun and the planet. And the tides is due to the moon and the sun. The low tide and high tides are produced on the earth because of the gravitational force of moon and the sun. That's all today. Thank you.